Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all in today's session. To access the notebook for today's session, you can access course page on my personal website arifbutt.me. You can click the appropriate link under this lecture resource column to view the notebook in NB Viewer and run it online in Binder. The other way is to download the notebook from the course GitHub account RFPUCIT, and all the notebooks for this course are housed in the public data science repository. You can click this link to download all the files. This is the Jupyter notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture number 3.19 of the third module, Python programming for data scientists, for the course titled Tools and Techniques for Data Science. Well, this is the 11th session on pandas, and today we are going to understand the concept of reshaping and transforming data frames. Reshaping, in simple words, is actually transforming the set of columns in a dataset into rows and vice versa. And this is the agenda for today's notebook. Well, my dear students, at times we need to reshape our data for data analysis purpose based on what kind of analysis we want to perform on our data. And these are the four different methods that can be used for this purpose: pivot, pivot table, melt, and crosstab. There are two other methods, stack and unstack, that are also used for the same purpose. But I'm sure after today's session you will be able to explore these two methods, stack and unstack, at your own. Although I think pivot, melt, crosstab, and pivot table, they are sufficient enough for all sort of reshaping and transformation requirements that a data scientist normally come across for data analysis purpose. So let's start with the pivot and pivot table methods. My dear students, both these methods can be called on a data frame directly or using pandas.pivot method, and in this case you need to pass the data frame as an argument. You can note the syntax of both these methods. Both these are used to transform or reshape our data frame and allows us to look at the data in different ways. The three main arguments that are passed to both these methods, pivot as well as pivot table, are index, columns, and values. Well, this index argument specifies the column to use as the resulting data frame's row index. The columns argument specifies the column to use as resulting data frame's column. And finally, the values argument specifies the column or columns to use for populating the resulting data frame values. If you don't mention this argument, all the columns will be used for this purpose. My dear students, I strongly recommend that you should go through the official documentation of this pivot as well as this pivot table method. I have mentioned the links over here. Let me straight away jump on to an example dataset for better understanding. Okay. Consider this dataset having four columns: date, city, temperature, and humidity. This dataset contains temperature and humidity level of three cities, Lahore, Murree, and Karachi, for three different dates, 20th, 21st, and 22nd of June. Suppose for better understanding of this data, I want the unique values of the city column to be at the row index and the unique dates to be at the column. I can use the pivot as well as the pivot table method for this, and this will be the data frame that will be the output of executing this line of code. Note the three cities at the row index. Also note multiple indices at the column level. The temperature and humidity were already there in the input data frame, and now we also have three unique dates under the temperature column and the same 3 unique dates under the humidity column. My dear students, do note the 18 values of temperature and humidity levels spread accordingly. Note over here we have for the 20th of June for Lahore we have temperature 38, and over here for 20th of June for temperature we have 38. So these values have been spread accordingly. Note that this data frame is the output of this line of code in which we have passed index, the city column as index. So the city column is over here and the date column as columns. So the dates, the unique dates, the 3 unique dates are over here. My dear students, similarly, if you want to keep the unique values of date column, the 3 different dates, to be at the row index as shown over here in this data frame, and the unique cities under the city column to be at the column, you can just swap these 2 arguments. To the index argument I have passed over here the date column, and to the columns argument I have passed the city column, and this is the output data frame. With this conceptual background, let's do this practically. So let's see the data set. This is a CSV file and this is the same data that I have shown over here as well. The same 4 columns: date, city, temperature and humidity. And let me pass the city column as index, the date column as columns to the pivot method. So this is the output which I have shown above in the image as well. Makes sense? We have the cities over here at the row index and the dates over here along the column. Over here I have used the pivot method. I can also use the pivot table method. No change. Simply you can see this. Suppose we want to see only the temperature or humidity column in the output data frame. Over here we are seeing both the humidity as well as the temperature column. In case if you just want to see the temperature column, you use the third argument to this pivot, that is values, and pass it the temperature and see the output. We have simply the temperature, these 3 columns, temperature with these 3 dates over here. And if you want to have an output data frame showing only the humidity, you pass the humidity column name to the values argument to pivot. So this is the resulting data frame showing only the humidity levels for the 3 cities for the 3 dates. And let me keep the date at the row index and the city at the column. You see this is swapped. We have the dates over here now, and the temperature for Karachi, Lahore and Murree is at this column place. Similarly, the Karachi, Lahore, Murree humidity is over here in the column place. And of course you can use the pivot as well as the pivot table for this purpose. They will give you the same output, no change. Hope this makes sense. Let's see another data set for digging deep inside the pivot and the pivot table methods. This dataset seems to be similar to the above dataset, but this is of course different. If you observe closely in this data frame, we have temperature and humidity for 2 cities, Lahore and Murree, and for 2 dates, 20th and 21st of June. Important point to note is that we have 2 values for this temperature on the 20th date and 2 values for this temperature as well as humidity for 21st date. So we have repeating values over here. My dear students, if you use the pivot method on this data frame, it will flag a value error because it does not know out of these 2 temperatures, 38 and 40, which value it needs to select for 20th June. The pivot table methods come for a rescue, and that is what I have shown over here, which will by default take the mean, the average of the 2 values, that is this 38 and this 40, the two temperatures on the same date for the same city, it will take the mean of these two temperatures and will write their mean, that is 39 over here. You note that under the temperature and the Lahore city, we have 39 over here for 20th. We have 39. I hope this is making sense. And similarly, if you note for the 21st, we have 39 and 37 under the temperature column of Lahore. And over here we have 38, which is of course the mean of 37 and 39. So pivot table can handle these duplicate values or multiple values. And similarly, if you simply swap uh, these if you want to use some other function, over here we have used the function, the default value of the function, that is mean, but over here you want to do something like median or mode or sum or count. You can pass the appropriate function to the aggfunc argument of the pivot table. So this is the another argument that you can pass to the pivot table, which will compute the sum of these two values. For example, for the Lahore city temperature on 20th, 38 plus 40, and it is 78. And over here 39 plus 37, and it is, I think, 76. So these are the sums and these are the averages. By default, if you do not pass the ag function argument to the pivot table and we have multiple values over here, it will take the mean, and if you want to pass a specific aggregate function, you can pass that as well. Okay, so with this concept, let's do this practically. So let me show you the dataset. This is the dataset I have described above. And note, we do not have unique values. Let me run the pivot method on this and it will flag an error, as I have already said. The error will say index contains duplicate entries, cannot reshape. So let me just comment this and use this pivot table instead and pass it the date column as index and the city column as columns, and you will see it will generate the output data frame with the mean values at the intersection of each. And if you want to use some other aggregate function, you use the agfunc argument to pivot table. I have shown this above as well. So this has now computed the sum of the two of values and placed at an appropriate cell. Great. Fine. For practice sake, let's consider this dataset as well, having over here 5 columns: gender, sport, age, and weight. Suppose we want to reshape this data frame and want the resulting data frame to have one record for each gender containing age, height, and weight. For each sport, that is cricket and basketball. So once again, we use the pivot table for that purpose and pass gender as index argument and sport as columns argument. Note, in the original data frame we have two values for age of females who play cricket: 21 female cricket 21 and female cricket 20. So we have two values. In this case as well, the pivot method will fail. That's why I have used the pivot table method. And the average of these two is of course 20.5, and that is what you can see over here. Female cricket age 20.5. So the default aggregate function is mean over here. Similarly, do map the rest of the values as well for crisp understanding. In the bottom over here, I'm passing another argument to the pivot table, and that is margins. I'm passing true to the margins. And once you pass the margins argument a true value, note the resulting data frame. Over here we have an additional column all. This has been added showing the subtotal or maybe the means. You have this all, which is the mean of these two values, and we have all, which is the mean of these two values. Let's see this practically. So this is the data set which we have discussing in the figure above, and note that I'm calling the pivot table, passing gender to the index and sport as columns. So this is the output. Hope this is making sense. And if we repeat this for pivot, of course this will generate an error, a value error, because we have duplicate values. Of course we can use the margin argument over here. Passing margin is equal to true, it will add an additional column in the output data frame containing the sum or averages of the sub values over here for each column. Let's see the dataset 4. I'm repeating the pivot table method on a different data sets so that you should have a clear understanding by applying these on different types of data and performing different analysis. This is the final one for this pivot. My dear students, the pivot method requires at least two arguments, index and column, while this pivot table method can work with the index argument only. Consider this dataset having the water need and the running speed of 5 different animals: elephant, tiger, zebra, lion and kangaroo. The data is of 3 elephants, 5 tigers, 7 zebras, 4 lions and 3 kangaroos. We have unique IDs of all of these animals, and we have the water need and the speed column. I hope that data is clear. Okay, if we pass only the animal column as index as shown over here to the pivot table, we get the average speed, average water need, as well as the average unique ID of all these. So if you need the data something like this, if you want to find out the average speed of the elephants, the average speed of the kangaroo, lion, tiger and zebra, and their average water needs, you can just pass a single column name to the index argument and skip the columns argument to the pivot table. Moreover, one more thing I want to show you, you can pass multiple column names to the index argument, 2 or more, as a list. So over here I am passing animal as well as the unique ID to the index. So we have over here, this is the output data frame having multiple indices, the animal as well as the unique ID. Both these are over here, and we can see the speed and the water need. Of course, this will help you out while using the lock method on elephant, kangaroo, lion, tiger and zebra. Let's see this practically. So this is our data set that we have discussed above. Let me pass only the animal column to the index argument of pivot table. So we have the animal over here at the index, and we have the average speed and average water need. Forget about this unique ID. This is not required probably. My dear students, you can always apply aggregation function on this new data frame. This is df1. You can apply any aggregate function using the arg method. Over here I am getting the mean of the entire series, that is speed, and of course you can get the mean of the speed as well as water need in one go. Moreover, like I have already said, you can perform multiple indexing by passing 2 columns to the index, and this is the output. You see we have the 3 records of elephant, the records for kangaroo, lion, tiger and zebra separately. I hope we have seen this in our group by session as well. Okay, so I think enough for the pivot and the pivot table method. Let's talk about melt now. My dear students, similar to pivot and pivot table, this pandas melt method is also used to transform or reshape data. The belt method is used to change the data frame format from normally from wide to long. Uh, Let me describe the arguments and behavior of this melt function with an example straight away using this image for better understanding. Okay. Now consider this data frame that has four columns showing the temperature of three cities, Lahore, Karachi and Murray, for 7 days of a week. Let's suppose these are the temperatures of these three cities for these 7 days. We can use pandas melt method where one or more columns are identifier variables while all other columns are considered as measured variables. Since over here I have just passed the day column, this day column, as id underscore vars, which is the identify variable to this melt method. Note the rest of the columns, that is Lahore, Karachi and Murray, they all have come up over here under the column named variable. So this is a vertical format. This is a horizontally spanned data frame. This is a vertically spanned data frame. All these three columns have come up over here now. Moreover, all these values have come up over here under the value column. You can easily match the values. The temperature of Lahore on Monday is 32. The temperature of Lahore on Monday is 32. For the temperature of, let's suppose, Karachi for Sunday is 77. Karachi Sunday is 77. Remember, these are just hypothetical temperatures. They do not exactly map to the temperature status of these cities. And of course, my dear friends, you can always assign appropriate names to these column names using the var underscore name argument to the melt function. We can give this column an appropriate name. Similarly, we can assign appropriate name to this value column using the value underscore name argument to this melt function. And maybe we can assign city name over here and temperature name over here respectively. Let me again describe a variant of the same data set to you, and probably this is shown over here, what I was saying. You can note over here, other than the id underscore vars argument, I'm just passing the day. I am passing value underscore vars as Lahore. So this has made var underscore name as city. So this has made this value, this column name as the city, and value underscore name is equal to temperature. So this has made this column name as temperature. Note these two arguments, var underscore name and value underscore name. These two arguments to the melt function are used to give a name to these two columns. Note over here we have the names as variable and value, and we have used var underscore name to give this column the name city, and value underscore name argument to give this column the name temperature. Other than these two arguments, I have used another argument to the melt function over here, that is value underscore vars. And to this value underscore vars argument, I can pass one or more column names. If I don't pass any value to this, all these values will be spread under this column. But over here I have mentioned that please give me the values of only Lahore city. So it has given me only the values of Lahore city. Note the output of this data frame. This data frame contains the temperature of only Lahore city. while over here, if you see, we have the value for the Lahore, Karachi as well as the Murray city. So this is another optional argument, value underscore vars, and over here below in this image I have passed Karachi as value underscore vars. So this is the output data frame. Note under the city column we have only Karachi now. I hope this is making sense. Okay, let's see this practically. So this is as usual the data set which we have discussed above. Let me call melt on this, and over here I'm just passing the data frame and the id underscore vars argument, and I'm passing the day to the melt method, and you see this is the view of the resulting data frame. This day column, all the 7 values are appearing over here for all the 3 cities over here, and these all values are populated under the value column. So this is the default name of this column, variable, and this is the default name of the column, value. And of course we can give them name, var underscore name city, value underscore name temperature. Let me run this. You see the only difference is now we have appropriate column name, and over here I am showing what I have said, that if I want to get the values of only the Lahore city, so this is giving you the value of only Lahore city, the temperature of Lahore city only. And if I mention Karachi over here, you get the output data frame having the values of Karachi only. And you can of course achieve the similar result from this data frame using this Boolean indexing. Great. And of course, my dear students, you can apply aggregation function on the new data frame as well. Let's suppose that this is the resulting data frame that we have created using the melt. Let me apply an aggregation function on this. Aggregation function on the temperature column, and the function is mean. So I've got the mean of this entire column. Great. And similarly, I can get the average temperature of only Lahore. I have used this Boolean indexing style of getting only the resulting data frame having record of Lahore only. Let me show this to you like this. Let me copy this, paste this over here. So over here we have only the records of Lahore. So I'm getting the mean temperature of Lahore only now. And over here, of course, I am getting only the temperature of Karachi. Let me copy this, paste this over here. So this is the resulting data frame. I am applying the ag function, passing mean. We are getting the mean of it. Great. Okay, so finally, let me talk about the crosstab method as well, that is normally used for quickly comparing categorical variables. The cross table is also known as contingency table, that displays the frequency distribution of variables. Let me straight away jump on to the example data set. I think you will be able to understand it. So over here, this is the data set. We have 3 columns: city, gender and age, and for city we have these records for Lahore and Karachi and Islamabad and Multan. We have the gender and the age. Suppose we want to get the frequency distribution of male and females. So we will pass the city column as index argument to this crosstab, and this gender as columns argument to this crosstab. So it will return the frequency table. So let's see this. We are passing to the crosstab function this city as index because we want to keep it on the horizontal axis, and Along the column side, we are passing the gender over here, and see the reshaping that crosstab has done. So this tells us that we have uh, two females from Islamabad, two males from Islamabad, one female from Karachi, two males from Karachi, and of course you can verify this from here. The power of this crosstab will be very apparent to you once you will be applying it on very large data frames. Over here we have just 14 records, and we can easily find out ourselves that we have two males in Lahore and three females in Lahore. And the same is the result over here, three females and two males. But if the dataset contains thousands of records, then of course the crosstab will come very handy to solve such issues and find the frequency count of different elements. And similarly, you can also get the count of each by adding the margins column to the crosstab. Passing true to this will add another column, that is all, that will give you the sum of it. We have seen margin in the pivot table as well. And instead of getting the frequency, that is the count, you can get the percentage. If you use the normalize method of crosstab, you pass true to this and you get the frequency. So this is the percentage, rough percentage of this. And suppose if you want to apply some ag function, you can use the ag func argument to the crosstab. Let me run this, and you see we get the average, the mean, average age of the male and the female in different cities. And for that, of course, I have to pass the values argument as well. And to the values argument, I'm passing age over here. I hope this makes sense. Today I have tried to give you an overview of four different methods: the pivot table, melt, and crosstab. And all are used to reshape your dataset for better analysis of data. My dear friends, the use of these methods is a bit tricky. I've tried to give you a lot of practice. However, practicing these on different datasets will make you good at restructuring and reshaping. So I strongly suggest that you should practice these methods a lot, and say me farewell for more or less this second last video on Pandas. So that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session, and expectedly that session will be on a time series data, and that will be the last session on Pandas. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning, and Allah Hafiz.